Morning students. Today's topic is properties of determinants. This is the last topic of the matrices and determinants unit, second unit. Okay. In this class we are going to learn the properties of determinants and the problems. First property. A determinant is unchanged when the rows are changed into the columns or columns into rows. Means a determinant is unchanged, means determinant is not changes when the rows are changed into columns or columns into rows. Means rows are changed into columns means that is transpose of a matrix. That means determinant of A equal to determinant of A transpose. Both are same. Okay. For example, A1 B1 C1 A2 B2 C2 A3 B3 C3 determinant equal to, I am interchanging this A1 B1 C1 rows into columns, second row into second column, third row into third column. Means it is, suppose if it is A, this is A transpose, both the determinant values are equal. That is the first property. Okay. Next, second property, that is determinant of A. Second property, if two rows or columns of a determinant are interchanged, then the sign of determinant changes. The sign of determinant changes. Means if two rows, for example, I am here taking R1, if find only if R3, means R1, R3 interchanges. Means here R1, A1, B1, C1, it is R1. A2, B2, C2, it is R2, row 2. R2 means row 2. A3, B3, C3 means it is R3, means row 3. I am interchanging here R1 and R3. Two rows are interchanged, means A3, B3, C3 is first row and A1, B1, C1 is second row. Interchange. Then the value of determinant will be only minus, extra minus will come. What is this value? We get extra minus. If you interchange two rows or columns also same. If you interchange any two columns, then also the sign of determinant will be changes. Value positive unte negative aitundi, negative unte positive aitundi. Next, third property, if two rows of a determinant are identical, then its value is 0. If two rows of a determinant are identical, then its value is 0. Means if two rows or columns also it is applicable, two rows or columns are identical, then determinant value is 0. For example, in this determinant matrix, A1 B1 C1 A2 B2 C2 A3 A2 B2 C2 means here second row and third row are same. Identical means same, so directly the determinant value is 0. No need to expand it, that we can directly put it as 0. For example, A1 A1 C1 A1 A2 A2 C2 A3 A3 C3. In this determinant, first column A1 A2 A3, second column A1 A2 A3 are same, means identical, then determinant is 0. Means if two rows or columns of a determinant are identical, means same, then its value is 0. No need to expand it and find out, we have to put it as 0. Next, third one, if each element of a row or a column be multiplied by the same number k, then the value of determinant is multiplied by k. If each element of a row or a column is multiplied by the same number k, then the value of a determinant is multiplied by k. That means, I will see the example. Suppose in this first determinant matrix, every element of a row every element of first column is multiplied with k. Then the value, this determinant value is k into k times A1 B1 C1 A2 B2 C2 A3 B3 C3. ఒక కాలంలోని ఎలిమెంట్స్ అన్నీ కేతో మల్టిప్లై చేసి ఉంటే కే అనేది అవుట్ సైడ్ అవుతుంది, కే టైమ్స్ ఆఫ్ డిటర్మినెంట్ అవుతుంది. ఆర్ ఇక్కడ సెకండ్ రో Ka2, Kb2, K3. Second row is multiplied with K. Then K is outside. That determinant, total determinant value equal to K into A1, B1, C1, A2, B2, C2, A3, B3, C3. Row or column, any row or any column, if multiplied with K, constant K, then the K comes, K times the original determinant will come. Okay. Next property, fifth property. If each element of a row is the sum of two quantities, the determinant of can be expressed as the sum of two determinants. Okay, if each element of a row or a column is the sum of two or more quantities, then the determinant can be expressed as the sum of two or more determinants. For example, if you take this determinant, in this determinant a1, b1, c1, d1 plus d1, a2, b2, c2 plus d2, a3, b3, c3 plus d3. In this third column is sum of two elements. Each element of row or column, here I am taking column, is sum of two quantities. ఎవ్రీ ఎలిమెంట్ అందులో ఆ కాలంలో ఉన్న కానీ రోలో ఉన్న ఎవ్రీ ఎలిమెంట్, ఈచ్ ఎలిమెంట్ మస్ట్ బి సమ్ ఆఫ్ టూ క్వాంటిటీస్. దెన్ దిస్ టోటల్ డిటర్మినెంట్ కెన్ బి ఎక్స్ప్రెస్డ్ యాజ్ సమ్ ఆఫ్ టూ డిటర్మినెంట్స్. ఈచ్ ఎలిమెంట్ ఉంటే ఆ రోలో ఆర్ కాలంలో, దెన్ డిటర్మినెంట్ కెన్ ఆల్సో సమ్ ఆఫ్ టూ డిటర్మినెంట్స్. ఫస్ట్ డిటర్మినెంట్ a1, b1, c1, a2, b2, c2, a3, b3, c3 ఫస్ట్. నెక్స్ట్ ప్లస్ determinant of a1, b1, d1, a2, b2, d2, a3, b3, d3. Okay, this like this. Sum of two elements that will come. Next, if to each element of any row of a determinant be added with k times the corresponding elements of any row, any one or more rows, then the determinant remains unchanged, row or column. If to each element of any row or column of a determinant be added with k times the corresponding elements of any one or more rows or columns, then the determinant remains unchanged. What is the meaning of it? If any elements of row is added with another row with multiplied with k, then determinant will be unchanged. For example, here first column, if you take columns or rows, first column a1, a2, a3 is added with k b1, k b2, k3. ఫస్ట్ కాలం కి ఏం యాడ్ చేశారు? kb1, kb2, kb3. kb1, kb2, kb3 అంటే మల్టిప్లైడ్ విత్ సెకండ్ కాలం, మీన్స్ c1 ఇంప్లైస్ c1 ప్లస్ kc2. సెకండ్ కాలంని మనకున్న మ్యాట్రిక్స్ ఏంటి? a1, b1, c1, a2, b2, c2, a3, b3, c3. సెకండ్ కాలంని kతో మల్టిప్లై చేసి యాడెడ్ ఫర్ ఫస్ట్ కాలం. దెన్ డిటర్మినెంట్ డస్ నాట్ చేంజెస్. ఓకే, నెక్స్ట్ ఫర్ ఎగ్జాంపుల్ రో a1 ప్లస్ ka2 ప్లస్ b1 ప్లస్ kb2 ప్లస్ c1 ప్లస్ kc2. ఇక్కడ ఏమైంది? ఫస్ట్ రో ఈజ్ a1, b1, c1. ఈ ఫస్ట్ రో యాజ్ ఇట్ ఈజ్గా ఉంది. ఆ రోకి ఏం యాడ్ చేశారు? సెకండ్ రోలోని ఎలిమెంట్స్ అన్నిటినీ a2, b2, c2ని kతో మల్టిప్లై చేసి ka2, kb2, kc2 యాడ్ చేసి ఫస్ట్ రోకే యాడ్ చేశారు, మల్టిప్లై చేసి. దెన్ డిటర్మినెంట్ డస్ నాట్ చేంజెస్. మీన్స్ దిస్ డిటర్మినెంట్ వాల్యూ ఈజ్ ఈక్వల్ టు సేమ్ ఒరిజినల్ డిటర్మినెంట్ వాల్యూ. దిస్ డిటర్మినెంట్ వాల్యూ ఈక్వల్ టు ఒరిజినల్ దిస్ డిటర్మినెంట్ వాల్యూ. ఇయర్ r1 is r1 plus k r2. Here c1 plus k into c2. అంటే ఒక కాలంని second column is multiplied with k and added to C1, then determinant does not changes. Here R2 row 2 elements are multiplied with k and added to row 1, then determinant does not changes. I will take this proof. Okay, I will prove this one. So first property, I will repeat. First property is that determinant of A equal to determinant of A transpose. And second property is if you interchange two rows or columns, then determinant sign will be changes. Third property, if any two rows or columns are identical, then determinant value is 0. Next, if each element of a row is multiplied with k or column multiplied with k, its determinant value is k times the original determinants. If sum of two elements, any row or column is sum of two elements, then two quantities, then the determinant is also sum of two determinants. Okay, if each element of any row or column is determinant be added with k times the corresponding elements of any row or column, then determinants does not changes, remains the same. That is it. ఓకే, ఒక రోలోని ఎలిమెంట్స్కి లేదా ఒక కాలంలోని ఎలిమెంట్స్కి ఇంకో కాలంలోని ఎలిమెంట్స్ని కేతో మల్టిప్లై చేసి యాడ్ చేస్తే డిటర్మినెంట్ డస్ నాట్ చేంజెస్. ఈ ప్రాపర్టీని మనం ప్రాబ్లమ్స్లో ఎక్కువ యూజ్ చేస్తాం. ఓకే, ప్లీజ్ కాన్సంట్రేట్. I will prove this property. I will take this proof of this one. Both the determinants will be equal. How they will equal we will see in the next slide. Next, A1 plus KA2, B1 plus KB2, C1 plus KC2, A2 B2 C2, A3 B3 C3 determinant. By using which property? Fifth property, each element of row or column. Okay, fifth property, by using fifth property, it is first row is containing sum of two quantities, therefore it can be written as sum of two determinants, that is A1 B1 C1, A2 B2 C2, A3 B3 C3 plus another determinant KA2 KB2 KC2, A2 B2 C2, A3 B3 C3 by using fifth property. K times ఉంది కాబట్టి this one is sum of two quantities first row, therefore it can be expressed as sum of two determinants. Next, by using another property, here every element is multiplied with k. Every element of row is multiplied with k, therefore its determinant is k times. Okay, it will k is outside. A1 B1 C1, A2 B2 C2, A3 B3 is same, and k is outside in the first row. So A2 B2 C2 we will get A2 B2 C2, A2 B2 C2, A3 B3 C3. Okay, next, two rows are identical here. First row is A2 B2 C2, second row A2 B2 C2. Two rows are identical, therefore total determinant value is 0 by using third property. This is as it is, plus k into 0. K into 0 means 0, only this determinant will come A1 B1 C1, A2 B2 C2, A3 B3 C3. That is, this second row elements are multiplied with k and added to first row, then determinant does not changes. Means the meaning, the property, this is R1 implies R1 plus KR2. If you take k equal to plus 1, if you take k equal to 1 means it will come R1 equal to R1 plus R2. Means if you add any two rows, then determinant does not changes. Okay, if you take k equal to minus 1, then R1 implies R1 minus R2. Means difference of two rows, then determinant does not changes. Columns also same, C1 plus C2, R plus C3, then determinant does not changes. Okay, these are the 6 properties And this sixth property we will use, mostly we will use this sixth property. Okay, next problems. We will see the problems related to properties of determinants. First problem, prove that determinant of 1, 1, 1, A, B, C, B plus C, C plus A plus B equal to 0. Okay. I am taking LHS 1, 1, 1 determinant A, B, C, B plus C, C plus A plus B. I am here doing R3 implies R3 plus R2. What is the R3? This is R1, row 1, first row. This is second row, R2. This is third row, R3. I am adding R3 to R3 plus R2. R3 plus R2. If you add R3 plus R2, write it in the third row. Okay. Second row, third row add చేసి థర్డ్ రోలో రాయాలి. సో ఫస్ట్ రో సేమ్ యాజ్ ఇట్ ఈజ్ A1 1 1 1. సెకండ్ రో ఈజ్ సేమ్ ABC. థర్డ్ రో ఈజ్ ఈక్వల్ టు R3 ప్లస్ R2 మీన్స్ యాడ్ A ప్లస్ B ప్లస్ C ఫస్ట్ వన్. నెక్స్ట్ A ప్లస్ B ప్లస్ C. These two elements will be added. A plus B plus C. A plus B plus C. Next these two elements are added. A plus B plus C. So and in the third row, if you take this one, A plus B plus C into 1, A plus B plus C into 1, A plus B plus C into 1. Every element is multiplied with A plus B plus C. So K times, K into, K ki badal ikkada emundi A plus B plus C. So here A plus B plus C is outside. Okay, A plus B plus C will come outside. Next 1 1 1 A B C. Here A plus B plus C into 1, A plus B plus C into 1, A plus B plus C into 1. So A plus B plus C outside means we will get 1 1 1. So here first row and third row are same, 1 1 1 1 1 1. Therefore determinant of this matrix is 0. So A plus B plus C into 0, that is equal to 0, that is RHS. Okay. Next property. Sorry. Next problem. Show that 1A square, 1B square, 1C square equal to determinant equal to A minus B, B minus C, C minus A. So I am taking LHS 1A square, 1B square, 1C square. I am doing here first R2. I am fixing the first row as it is. First row ni as it is ga unchukoni. Second row, third row I will change. R2 equal to, R2 implies R2 minus R1. R2 minus R1. R3 implies R3 minus R1. So first row is same. R1 doesn't changes. R1 is same, 1A square. Second row R2 implies R2 minus R1. R2, what is the R2? Second row 1B square, and first row 1A square. This is R2, this is R1. R2 R1. So minus. So 1 minus 1 corresponding elements, 1 minus 1 0, B minus A. Second elements B minus A, B square, third B square, A square. So B square minus A square. Similarly, R3 implies R3 minus R1. So R3 means 1C square. R3 minus R1, this 1 minus 1 0. Next C minus A, C comma A, C minus A, C square minus A square. That is, I am doing R2 implies R2 minus R1, R3 implies R3 minus R1. Next, and this B square minus A square can be written as B plus A into B minus A. C square minus A square can be written as C square minus A square, means C plus A into C minus A. I am writing here 1A square as it is, 0 B minus A, this B square minus A square is B minus A into B plus A, 0 C minus A in C minus A, C minus A into C plus A. Next, if you take first row, second row elements, it can be written as 0 can be written as 0 into b minus a. Next only b minus a, so 1 into b minus a. Next b minus a into b plus a. Okay, means b plus a into b minus a. Means every element is 0, b minus a, 1. Element is multiplied with b minus a, so b minus a is outside will come. And here 0 into c minus a, 1 into c minus a, c plus a into c minus a. Every element is multiplied with c minus a, so c minus a is outside. From the second row, b minus a is from the first row. Second row, b minus a is outside. Third row, c minus a is outside. So the determinant of first row is same 1a square. Here second row 0. b minus a outside means 1. b minus a outside means b plus c. Third row 0, 1, c plus c. Its determinant. Its determinant is, I am expanding through the first column. 1 into its minor, minus 0 into its minor, plus 0 into minor. So zeros will be goes 0 into something is 0, therefore only 1 into. So b minus a into c minus a, so 1 into minor row and column, this determinant 1 b plus c, 1 c plus c, ad minus bc, so 1 into c plus a minus 1 into b plus a. That is b minus a into c minus a, 1 into c plus a means c plus a, minus 1 into b plus a, minus to multiply jali, b minus a, c minus a, c plus a, minus of b, minus of a, minus a plus a cancel, we get c minus b, b minus a, c minus a, c minus b. But answer is, what is the answer? Our answer is a minus b, b minus c, c minus a. So we have to convert this b minus a, c minus a, c minus b. Here minus is common in a, b minus a, minus of a minus b will come. C minus a is as it is. In c minus b also minus common, minus of b minus c. This minus and minus plus, so a minus b into b minus c into c minus a, it is RHS. Okay. And how to take this R1 plus R2, R2 minus R1, R3 minus R1 will come. If you do the more problems practice, by practicing it will be easily to find. Next, third problem, if omega is cube root of unity, then prove that 1 omega square 1 omega square 1 omega determinant equal to 0. And here given omega is cube root of unity. Cube root of unity means cubed root. Cubed root means x equal to 1 to the power of 1 by 3. That is x cube equal to 1. That is x cube minus 1 equal to 0. Means here degree of x is 3. So we get 3 roots. 3 values aside, that is named as 1 omega square. So if you add 1, we have two properties. If omega is cube root of unity, 1 plus omega square equal to 0, omega cube equal to 1. We have to remember this 1. If omega two results, if omega is cube root of unity, then 1 plus omega square equal to 0 and omega cube equal to 1. Next, LHS 1 omega square square 1 omega square 1 omega. I am taking here C1 equal to C1 plus C2 plus C3. C1 implies C1 plus C2 plus C3. What is the C1? This is C1, first column. This is C2. This is C3. So add the elements. 1 plus omega square. Right in the first column. So next omega plus omega square plus 1. Next third one omega square plus 1 plus omega. Okay, first column is changed. Next remaining two columns omega square 1 square 1 omega same. And from the results we have 1 plus omega square equal to 0. Therefore here 1 plus omega square, that is 0. Here also 1 plus omega square equal to 0. 1 plus omega square equal to 0. 0, 0, 0, omega square 1, omega square 1, omega. So this column is total 0, 0. Therefore, determinant value is also 0, that is RHS. Next problem, last problem. Prove that determinant of a plus b plus 2c, a, b, first row again. Second row, c, b plus c plus 2a, b, c, a, c plus a plus 2b equal to 2 into a plus b plus c whole cube. So take it first. LHS, determinant of a plus b plus 2c, a, b, c, b plus c plus 2a, b, c, a, c plus a plus 2. I am here taking c plus c1 plus c2 plus c3. So add, it is c1 first column, and it is second column, and it is third column. So add the elements of all the columns. So first column, first element, this one, plus second column, this element, plus this element. A plus A, 2A, B plus B, 2B plus 2C. Next, add these three elements. 2A already there, B plus B, 2B, C plus C, 2C. Okay. Next, add these three elements. A plus A, 2A, already 2B is there, 2B, C plus C, 2C. Okay. 2A plus 2B plus 2C. Remaining two columns are as this. Okay. A, this column A, B plus C plus 2A, B, B, C plus 2A plus B. And in this column, every element is 2A plus 2B plus 2C into 1, 2A plus 2B plus 2C into 1, 2A plus 2B plus 2C into 1. So 2A plus 2B plus 2C is K times K. It is K. So K is outside. Means 2A plus 2B plus 2C is outside. We will get 1, 1, 1, 1. A, B plus C plus 2A plus A, B, C plus A plus 2. It is. Next I am fixing here 1, 1, 1. 3 ones are came. So I am fixing this row as it is. Next second row R2 minus R1 and R3 minus R1. Okay, to get zeros. R2 minus R1. 1 minus 1, 0. B plus C plus 2A minus A. 2A minus A means plus A. So it will get A plus B plus C. Next, B minus B, 0. 0, B, A plus B plus C, 0. We get that answer here. Second row, 0, A plus B plus C, 0. Next, third row, R3 minus R1 means 1 minus 1, 0, A minus A, 0, 2 zeros, and C plus A plus B minus B means 2B minus B means B, A plus B plus C. Okay. Here 0, 0, A plus B plus C. So its determinant, its determinant expanding through first column. These two, 1 into its minor, minus 0 into minor, plus 0 into minor. These two zeros, 0 into something is 0, only 1 into. Okay. So 1 into this 2A into common, 2 into A plus B plus C, 1 into this determinant A plus B plus C, 0, 0, A plus B plus C. Determinant is AD minus BC, AD A plus B plus C into A plus B plus C, 0 into 0, 0. So 2 into A plus B plus C, A plus B plus C into A plus B plus C minus 0. So A plus B plus C into A plus B plus C into A plus B plus C means A plus B plus C whole cube. So 2 into A plus B plus C whole cube, that is RHS. I am here, first I am doing here, first of all I am doing C1 implies C1 plus C2 plus C3. In that, after doing this one, we are getting elements are same, 2A plus 2B plus 2C. So 2A plus 2B plus 2C is common, and here we are getting 1, 1, 1. So R2 one row is fixed, remaining two rows I am performing. R2 minus R1, first one, that is writing in the R2. R3 minus R1 I am writing in the R3. then expand determinant, we get the answer. Okay, next homework problems. Prove that determinant of 1, 1, 1, a, b, c, a cube, b cube, c cube equal to a minus b, b minus c, c minus a into a plus b plus c. Okay. Next, prove that determinant of b plus c, a, b, c plus a, b, c, c, a plus b equal to 4a, b, c. Next, third problem, show that 1 plus a, 1, 1, 1 plus b, 1, 1, 1, 1 plus c equal to a, b, c into 1 plus 1 by a, 1 by b, 1 by a plus 1 by b plus 1 by c. Okay, try to solve these problems. If you have any doubts, ask me. Okay, thank you.